What's up guys, this is Professor Spawn and we have seen in the past tutorial about the tree map as well as the tree set. So I'm just going to open up only a single class which is a tree map, and we have seen that in tree map the keys were sorted right in a natural ordering, right? So here we have the data as, if you put any data as here we are considering only string, right? So if you put the string in any order and if you print the map, the map will be ordered naturally, right, based on alphabets. So A will come first and it will be sorted alphabetically as the keys are string. But then the question is, how does tree map do that internally? So if you go inside this tree map class and if you see that there is one instance which is called as a comparator, right? So, and if you see here inside this generic, this is basically a key, right? And there is a comparator interface which is used to maintain the order in the tree map, right? So the order followed by this comparator is natural ordering. For example, if it's a string, then it will be sorted alphabetically from A to Z. If it's an integer, it will be sorted based on the int values from 0 to 9 or whatsoever, right? And if you go inside this comparator class, you notice that this is an interface. And if you notice carefully, this is basically a functional interface. So what is exactly a functional interface? A functional interface are interfaces which has only one abstract method. And this comparator has only one abstract method which is named as compare. And if you notice, this compare abstract method returns an integer value and it accepts to parameter the two object of type T. But if you scroll down, there is one more method. This is one more abstract method, and you might be saying that how a comparator is a functional interface when the definition for the functional interface is it should have only one abstract method. So the thing is, this equals method is basically taken from the object class, right? So this will not be counted towards the abstract method. So please note this, the comparator has two abstract method, but one of them is taken from the object class, right? So that will not be counted as the abstract method of the comparator interface. Remember this. This is very important. And if you go down, there is a default method. Remember, it still holds true that the interface still has one abstract method. This is a default method, and if you scroll down, we will have one more default method, right? So the thing is, the comparator interface has only one abstract method, and that's why this is called as a functional interface. And functional interface was added in JDK 8. Remember this. So this comparator interface helps you to sort the elements inside a tree map. Rather, it sorts the keys inside a tree map data structure, right? So on the similar line, what we are going to do is I have created an employee class inside a sorting package. So I've created a sorting package, and inside that I have created an employee class. Okay. So what I'm going to do is I'm going to have few variables here. So I'm going to have in salary, right? I'm going to have, let's say, string first name, and here I'm going to have, let's say, a last name. So here I'm going to have a last name. And what I'm going to do is I'm going to create the employee class. So I'm going to instantiate this employee, new of employee, right? And what I'm going to do is I'm going to create a constructor. So employee, and this constructor will have a salary. Along with that, it will have, the first name. Along with that, it will have the last name. And what I'm going to do is using this keyword, I'm going to initialize with the constructor argument, right? So I'm just doing, I have a constructor which accepts 3 arguments, and I'm initializing the instance variable with the parameters passed by the constructor. So this dot last name is equals to last name. Now I need to pass, the first is a salary. For example, I have 1000, The first name is, let's say, Spawn, or rather, the first name is Professor, and the last name is Spawn, right? Again, I'm going to create one more employee, and here I'm going to have, let's say, 1500 as a salary. The first name is John, and the last name is Wake. Let's create one more employee class. So I'm going to create employee 2 is equals to new of employee. This time this will have 2000 as salary. I can have, let's say, Michael, and I'll have here as Atherton. Okay. Now we have created three different employee objects with three different types of data, right? So we are initializing three constructor with the different values of data. Now what I'm going to do is I'm going to create an array list of employee, right? Employee array list is equals to new of array list, right? And what I'm going to do is I'm going to add all this employee inside this employee array list. I'm going to add employee. Similarly, I'm going to add employee 1, and I'm going to again add the employee 2. So I'm going to add the employee 2 here. Okay. So what we did is we created a three employee object with three different types of data. I have created an employee array list, right? And I've added all this employee inside this employee array list, right? Now what I'm going to do is I'm going to have collections dot sort method, right? So a sort method is basically this is basically doing a sorting on the collection. The collection can be a list, right? So if you see here inside this sort method actually accepts the collection of type list. Remember that you cannot pass a map here. So a sort method will only accept a list collection. For example, the array list is a type of a list. Similarly, we have vector, we have stacks, right? So you need to pass here the type of list. So as we have created the array list, so I'm going to pass the array list. But hey, this is actually giving me an error, right? Because this this array list is basically a type of employee, and this collections dot sort cannot sort this array list. And but I want this array list to be sorted. But the Java is now confused. You need to sort based on what? Based on salary, based on the first name, or the based on the last name. Like based on which parameter I need to sort this, the array list of employee. And this is where one more interface comes into the picture, which we call it as a comparable. So how do you use comparable interface in Java? So what I'm going to do is I'm going to implement a comparable interface, and here I'm going to pass the type of the type of object this comparable interface will take. So let's go into this comparable interface. Just like we have seen the comparator interface, there is one more interface which helps you to sort, and that interface is called as a comparable interface. And if you notice that it has one, the abstract method, so you can say that the comparable interface is also a functional interface. But remember that here we don't have that functional interface annotation, so that's not necessary. If you define one method here, so this is a functional interface. Okay, remember this. So inside this we have one abstract method, and we have seen in the interface, in the object oriented programming section, you have seen about the interface. If you have an abstract method, you need to override that. So what I'm going to do is I'm going to implement that method, which we call it as a compare to. Now it has, a compare to has an employee object, right? Now I have an object. As we know that, if you see this compare to method is basically, comparing between the two objects. And this is where we are going to write our sorting logic, right? So let's say that I want to sort the employee based on the salary. So how am I going to do that? So here what I'm going to do is this dot salary dot, you know, dot compare to, let's say that this dot salary is greater than O dot salary. So what I'm going to do is, for example, I'm going to have few methods. So if this dot salary is greater than O dot salary, return 1. Else if this dot salary is less than O dot salary, return -1, right? Else return 0. So if you notice, if this dot salary, that means the instance variable salary, that this object salary is greater than whatever or whatever object we are getting here, O dot salary, return 1. This is, you know, this is what happens inside a comparable interface. If it is less than O dot salary, then you return -1, and if else, 0. So 0 is for the equals case. So I'm going to write here the equals case, less than case. So I'm going to have a comment called as less than case, and here I'm going to have a greater than case. So now what I'm going to do is I'm going to run this class, and I'm going to do an sout based on the employee array list. So I'm just going to do an sout. So I'm going to run this employee class. This will build, and you will notice the output as the three different objects. So what I'm going to do is I'm going to instead use a for each loop here. So a for each e, this is a lambda expression, sout e dot salary, right? So I'm going to have e dot salary here. Okay. So here what I'm going to do is instead of that, I'm going to remove this, and I'm going to remove this bracket as well, the extra bracket. So basically what we did here is we created an array list of employee, we added the employee, we implemented a comparable interface, right? And inside this compare to, we write our own sorting logic, and we will see that how this list will behave. Remember that array list maintains the order of elements we put, right? So let's see what is the output of this. So I'm going to run this code, and we'll see the what salary we get. And if you notice, we get, you know, the salary as 1000, 1500, and 2000. But let's try to put the 2000 at the top, right? And what I'm going to do is, instead of that, what I'm going to do is I'm going to put here as 1 2, and I'm going to put here as, you know, the first I'm going to put the second, which is the 2000 employee with a 2000 salary. Then I'm going to put 1500. Rather, let's say that I'll put here as employee and here as employee 1, and let's run this code. When you run this code, you will notice that you are still getting the output as 1000, 1500, and 2000. So basically what happened here is this employee array list of employees getting sorted based on the salary. Now we have here jumbled the way we add the elements inside an array list, and this collections dot sort will apply the sorting algorithm, right? A sorting algorithm based on this logic, right? So this dot salary is greater than whatever employee object we get here, then it actually returns 1, and this will say that you need to sort it, you need to sort it out, right? If it is greater than, if it is less than the salary which we get, it says that you don't have to sort, right? And this is for the equals case. So let's try to get the first name. So what I'm going to do is I'm going to run this code, and you will notice that you'll get again in a sorted order. So basically, the array list is getting sorted based on the integer, right? But let's say that you want to sort based on the first name. So that's pretty much simple. So what you have to do is, instead of this, so I'm going to just comment this up, and here I'm going to write return this dot first name dot compare to, right, o dot first name. And let's run this code again. So if you run this code, right, you'll see that this has been sorted based on the alphabetical order, right? So J comes before M, right? And M comes before P. So this has been sorted based on the alphabets. Now let's try to print the salary and let's see what happens. So when I run this code, then the salary is also sorted, but somehow, okay, as we have been sorting this employee array list based on the name, right? That's why this the respective salary is getting printed. Let's try to print the last name here. So I'm going to print the last name, and let's run this code, and you will get the Vic because J comes before M, right? So we have Vic, then we have Atherton, then we have M spawn, right? So this is how the comparable interface works. But remember that I started this video with a comparator interface, and we will see that in the next video, and we'll also see what is the difference between the comparable interface as well as the comparator interface. Remember that these two interfaces in collections helps you to sort your collection, especially the list collection. Remember that, right? So collections.sort internally uses a Tim sort algorithm. This is an enhanced version of merge sort, which gives you a performance time complexity of O of log n, or rather O of n log n, and it internally uses a Tim sort. You can read about that on the internet. You will get to know much more detail about that. So this is all about the comparable interface, one of the first interfaces which we use it for the sorting, right? Sorting, the collection of the user defined class, right? So for example, if you have, let's say, I'm going to create one more element here, one more array list, and here I'm going to, let's say, have an integer, and I'm going to have an integer is equals to new of array list, right? Now I'm going to add some integers here. So for example, I will add 4 here, and integer dot add, let's say, 6 here, and integers dot add, let's say, 1 here. What I'm going to do is I'm going to use collections dot sort. I'm going to pass this integer, but this is not giving me an error. We'll see that why. And what we are going to do is we are going to use the for each method for this, right? And we are going to print each integer. So we are going to print the integer here. So let me comment this out for a moment, and let's see what is the output here. So if you notice, this is getting sorted numerically. So 1 came first, then it came 4, and then it came 6. But hey, it didn't give me an error when I applied the sorting of integers. Why? So let's go inside this integer class. And if you notice, this integer class implements a comparable interface. That's why the collections.sort didn't give you any error, and it sorted naturally, right? So integer class internally implements the comparable interface. Remember that, right? And also, if you notice, if you go to the string class, for example, let's go inside the string class, right? So this also implements the comparable interface. If you define instead of the integers. If you define, let's say, string, this will be sorted alphabetically, right? Because the string class also implements the comparable interface. So this is one thing I wanted you to know about this. So if you define any of your class and you want to sort you know the class data based on a certain field, you need to implement a comparable interface. In the next tutorial, we will see what is comparator interface, and we'll see the difference between the comparable as well as the comparator interface. So I'll see you in the next class. Till then, goodbye and see you.